focus in on individual tasks such as heart rate monitoring. We've been able to find some limited success. Video processing, as you know, is also incredibly computationally intensive, and so the question often comes down to whether we should offload that computation from the device onto the phone or computer or into the cloud. And so that, and there are trade-offs in each space there. Just before I go on, really quickly, and wrap up, just want to take a quick poll here. Just to better understand the audience makeup, how many people here are students right now? Any students? Okay. And how about teaching faculty? Yeah? Okay. So largely an academic audience here. Any people any people working in industry right now at a company? Anyone working in a startup? Okay, a lot of startup people. Cool. It looks like a lot of same hands, so maybe people are having multiple jobs here. Okay, well, if you'll permit me, I have a little treat at the end of this talk. But before I go on, I thought I'd just spend a few minutes to talk about some of the learnings that I've had over 3 startups in the last 15 years. This is something that I've brought up a few times and people seem interested in it, so I'll just bring it up. So, just a few lessons. Hiring, right? Whether you're hiring for your startup, whether you're recruiting for your research institute, or you're recruiting for, maybe it's different in academics, I shouldn't generalize, but certainly for companies and startups. In my first company, we just focused on getting really, really smart people, and high IQ, just incredibly brilliant people, and we just had a bunch of social problems. We just had a lot of team-related problems. And what I learned was that what we were looking for were skills, not just sheer IQ. So in my second company, we decided, that's it, we're going to hire people with a lot of experience, okay? We ended up with people with 20 years of experience, and we also ended up with people who looked like they had 20 years of experience, but in fact they had 1 year of experience 20 times, okay? Meaning they didn't actually learn anything during their 20 years, but were able to hide within the corporate veil. And so what we learned was that what we were looking for were people with wisdom, people with great judgment, people who are just right all the time. I'm sure everyone here knows, people like that, and I've just found that that's what we want to hire for. I've never come up with a good process on how to find such people, but I don't know, I guess sometimes you get lucky. Cultural fit. So people have asked, what is it that we look for at this, in the third company now? What have you learned? What is the most important thing? And I've just kind of concluded that cultural fit is probably the most important thing. Meaning, not as in like ethnic culture or whatnot, but as in whether people share your values, and will, and you can trust them to act autonomously on your behalf, or and will build a culture that will be attractive and appealing for people that you're going to be bringing on. So cultural fit was huge. That's probably the most important thing. So at Misfit, for example, one of the values that we share is always doing more with less. To do more with less is hard. If you ask an engineering team, hey, what do you need to make something twice as good? How do you make that device twice as fast? Then the answer is often, well, I need twice as many resources, or I need twice as many engineers. But if you ask, well, how do you make it 10 times as good? People aren't going to come back and say, well, I need 10 times the engineers. They're going to have to come up with a radical solution. And so, we are often asking ourselves that, how can we do more with less? If you're going to build, speaking of culture, if you're going to build a strong culture, you have to do it early. So if you're a small early stage company, or you're just forming a new team within your company, it's to get it done early. Basically, after around 50 people, the nature of your company doesn't really change that much. It's hard to change the fundamental nature of your culture. Hire and fire based on culture. It's very hard. Often it seems hard to let someone go who is just so amazing. You know, I'm sure you've been in that situation whether you've got like an amazing contributor to your team or your company, but you know they're just a real jerk. And you don't want to work with them. And I say in all cases, it's a very obvious decision, and that is you can't put up with that. You know, life's too short. We also talk about life work. You know, we're always trying to achieve work-life balance. And I think a lot of that presupposes that you don't actually want to work, that the work isn't actually enjoyable. And what we've learned at Misfit is that it's not about the balance, but about work-life integration. How do you integrate the two into your lives so that you're really living both to its fullest. I know I'm going to go into this fast, but this topic is going to come along. Leading. So stand up for what you believe in. This is something I've learned in previous companies. And have strong opinions, loosely held. So we love people, talking to people who have strong opinions about things, but having the flexibility to change those opinions is very important. Otherwise, you're just constantly in a stalemate. Execution. So if you're, for all of you people who are doing startups, remember, it's very easy to get focused on building a product, especially in Silicon Valley. And I kind of feel that's the case within Ho Chi Minh City and the tech scene there as well, that everyone's focused on building a really great product, and that's important, it's important to have a good product, but at the end of the year, at the end of the day, it's about having, you have to have a business, and you have to have what you do, whether it's inside a big company or for a startup, it has to be sustainable. Being lean, again, goes back to our shared value of doing more with less. This is actually a term of art. So there's a book called Lean Startup, which is actually quite popular. And if you haven't read it, I highly recommend it. It's highly applicable, not just for the startup world or for a big business, but it's also, I think it's applicable in life. And it's basically about rapid iteration and minimizing the cost of experimentation. So the book is called Lean Startup by Eric Ries. I think if I were to leave you with something in terms of lessons in business, give first, get later. I learned this from one of our great mentors, Chairman Li Ka-shing. I think there's a reason why he's the richest man in Asia, and that's because he lives with this, by this. And I remember when he told me about this, I just felt, yeah, that's how I want to be. So, any questions so far before I leave you with anything? Yeah.
I have a question.
I'm not sure if I speak in English or maybe I'm more English. So you guys been tuning a lot of algorithms to fit in this little device, and obviously you've come up with you have used standard methods, I don't know, gradient descent or whatever. So I'm wondering if you were able to use a library, tune it a little bit, or did you have to actually come up with new algorithms for solving those problems? And are you going to publish the results somewhere?
Có cần nói lại câu hỏi, chắc là mình nói lại câu hỏi luôn là có hỏi cô là ở Misfit thì thông thường trong các cái nghiên cứu mà mình sử dụng các cái kỹ thuật về machine learning thì mình sẽ dùng những cái code hoặc là những cái thư viện có sẵn và mình sửa lại để sử dụng, hay là mình có thiết kế riêng. Thì có lẽ lúc trước khi mà nói đến những cái bài toán mình đã có nói qua là đa phần những cái thuật toán mà chạy ở trên thiết bị nó yêu cầu cái tốc độ của nó phải rất là nhanh, có nghĩa là thuật toán của nó phải rất là tối ưu, và trên thực tế là đa phần mình đều phải làm những thuật toán mới. Kể cả ngay cả thiết kế ngay từ đầu chúng ta cũng phải thiết kế đi thiết kế lại khoảng 10 lần, 15 lần chúng ta mới làm ra được một cái mà nó cân bằng giữa độ chính xác và tốc độ của nó. Vậy nên để trả lời câu hỏi của anh thì ở Misfit tất cả các thuật toán mà được tạo ra đều là bắt đầu từ ban đầu hết. Thành ra là sau một thời gian làm đi làm lại cái quy trình đấy thì mọi người cũng quen. Tức là bao giờ cũng gặp một bài toán, việc đầu tiên là đi tìm đi thu hoạch dữ liệu, xong rồi có dữ liệu ở đầu ngồi căn quát ra nhìn dữ liệu xem là chúng ta có thể sử dụng được cái thông tin gì từ dữ liệu ở đây, và sau đó chúng ta bắt đầu sử dụng xây dựng một số cái model dựa trên những cái thông tin đó, và từ đấy chúng ta suy ra thuật toán. Cảm ơn. Any other question? Yes.
Thank you for your great talk. I had a question about this. You talked at the beginning of the talk about this wealth of knowledge about physical activities and so on. And I see two aspects. The first one is, how do you think that your first you're providing the signal, and then there is a different aspect which is to interpret the signal and application. How do you think that people in this business will be liable for the kind of information we provide, and how critical will it become to actually, because there's a difference between being precise in estimating the number of leaps or the number, the heartbeat and so on, which is just being precise on the quality of the signal, and the other aspect which is critical, which is to actually make sense of it. And I'm working in machine learning, in biology, and it's still so difficult. So I'm just very interested in having your answer about it.
So the question is around, what about liability, and what about maybe privacy of this information, right? Because we have so much data. So this question always comes up, and the technical answer is that there really isn't much liability. The reason why is because there aren't strong marketing claims, okay? So the only difference from a regulatory perspective, in the US, to sell a medical device, you have to have FDA clearance. So the Food and Drug Administration has to give you the clearance to commercially, to sell your product. And you get clearance based on basically data that you provide, and on how well you can support your claims. So basically, the only thing that differentiates a medical device and a non-medical device is the claims. So if you say, this cures cancer, you could literally have two products that are exactly the same, and if one says it cures cancer, or it helps you lose weight, then you have to provide data to show that you can do that. And if you can convince the FDA that what you're saying is true, then you have clearance to sell. If not, then you cannot have that marketing language. So that's the technical answer. You know, if you don't have medical claims, you're not a medical device, liability is a lot lower. And I mean, short of saying for entertainment use only, which is not the case, you know, there is, the liability is less. However, the privacy question remains. The question is, you know, all of this data is stored in the cloud somewhere. What happens to it, and what if someone starts using it for other purposes? And that is a lot more sensitive. And so you have privacy statements that are very upfront that people sign off on. At the end of the day, though, much of this data is actually not that critical. I mean, it's steps, you know, and the question is, you know, it's not like someone knows whether you have some disease or something, you know, so this data is not at that level yet. Now, when you start talking about heart information, heart rate, and blood pressure, now it gets to be more sensitive. And so all the companies like us are actually quite sensitive about that and have these privacy statements stated up front. And we also give people the right to delete, to move their information if they want. So, you know, that's kind of a long answer. Any other questions? Yeah.
You spoke about the difference between, say, steps and heart rate, but in fact you didn't directly measure the heart rate. It's what you inferred from your raw data. So are you even liable for that?
Yeah. So it depends. So you're, in terms of how directly something is measured, I guess that's a matter of interpretation. With the video-based heart rate monitoring, it is in some ways measuring it because of the color changes in the skin. We're able to do a limited amount of heart rate through accelerometry data. But if you think about it, all of the information that we're providing, steps, calories, distance, stroke type, all of that is inferred anyways, because the only thing you have is acceleration vectors in X, Y, Z directions. And so everything is in fact inferred. Like calories, we have to calculate it based on your BMI, your gender, your age, that kind of thing. Any other questions? Yes.
So I'm wondering whether you will use some sort of personalization in your device, because like health information that depends on individual. So for some level body temperature or blood pressure. So it's normal for one person to be lower or higher for another person. So what you can learn from a particular person to make a decision.
Right. So we actually have to gather some information from a person in order to personalize for them. And so, for example, the calorie, I'm not sure if I'm answering your question right, but for example, to calculate calories, we actually have to, that calculation is based on, their height, their weight, their gender, age, that kind of thing. I'm pretty sure that we'll be able to use the information that we're gathering to personalize things for people over time. Like we understand their sleep patterns, their activity patterns. I think the kind of experiences we can provide over time will be much better because we can contextualize it. If we know that a person is never active on weekends, we're not going to. Maybe the suggestion would be, hey, why don't you consider doing a workout on a weekend? But if we know they always exercise on Wednesdays, if you deploy a coaching program, you're not going to coach people, hey, try to be more active on Wednesdays, because you already know that they already are.
So the second question that you consider decision based on a single device or some device nearby, maybe if device may be popular in the future, so you can decide something based on this device nearby. For example, if you recognize activity, so if you based on the multiple device nearby, so you can recognize activity easier than based on a single.
Oh yes, so multi-device is very interesting. I mean, having if you have more than one sensor, it gets way easier to do any of the things that we're doing. So especially activity classification. So there are wearable products out there that are 2 devices, one for your foot and one for your wrist or something like that. And so doing the sensor fusion work across position makes it way easier. I mean, what's harder is when you only have one position, or when you have one position and you don't know what that position is. And so with Shine, we actually have to detect where the position is and guess what infer what the position is, and then apply the mathematical models because the number of steps that if you have a fixed model and it's just for the wrist, and then you move that to the neck, your steps are going to be different. And so we actually will adjust for position.
Have you think of having an API for independent developer to create application on the platform?
Oh yeah, for sure. So we actually have a pretty extensive developer program, probably one of the larger developer programs out there. So if you go to build.misfit.com, build.misfit.com, Misfit.com, there are actually 3 ways to integrate it. So we have an API where you can just grab data, pretty easy. So that's automated. We also have a software development kit, an SDK, so you can actually read from our firmware and get data directly from the device to your app. So if you're making an app, you can actually apply to get our SDK and have the device communicate directly to your app without having to use our app, which is very cool. Not many devices do that. And the last thing is we actually have our Misfit Scientific Libraries, the MSL, part of what we heads up. And basically these are the libraries for our activity quantification, classification, sleep quantification and classification, heart rate monitoring, all of that freely available to anyone, hardware developers, apps to use. And the only thing we ask in exchange is that we get a copy of the data, and mostly it's so that we can improve the science. And so there are actually activity trackers that compete against us that we provide the algorithms for on the market right now. So that it's, yeah, we're very open in that regard.
Thank you for your presentation. In your talk, you mentioned about energy consumption of machine learning algorithm. I'm very curious about that. Can you share with us about your investigation or some investigation about the consumption, the real consumption of energy of a machine learning algorithm, for example? If you have done previous with any investigation, just share with us?
Sure. I can talk to you at a high level. I don't know the exact numbers. Maybe we will know and can talk about how we've optimized some of our algorithms. But literally, we've taken a full stack approach. The chips we use, the hardware layout, you know, what chips are near each other, that type of thing. The types of algorithms we use have highly optimized for power management. So for example, for a time we were using EEPROM instead of Flash because reading and writing from Flash is in fact a lot more expensive in terms of energy than EEPROM. You know, we try to minimize the number of divisions that we use in our algorithms so that we don't, you know, it's just much more computationally complex, at least for the processors that we use. So we take a very now, we may not take power management from a design perspective enough. So for example, we eliminated a button. If we had a button, life would be so much easier because you would just press the button and it turns on. But we actually do tap detection, and that's actually quite power intensive. So I know we would have loved to have a button, but no, we don't have a button because if we had a button, it would not, shine would not be shine. It just wouldn't look the same. And so, so that was hard. I don't know if you want to comment a little bit about Shine to work with for 6 months. And you know, I mean, we're doing a lot here. We have the sensor on all of the time, listening for a rapid tap or, you know, a slower, human motion. We're doing the computation to extract all that information. We're doing Bluetooth data transfer all of the time. We're lighting up very bright, 12 very bright lights, okay? And we're doing that for 6 months at a time. It's pretty cool.
Yeah, thank you, Sam. Thì để trả lời câu hỏi của bạn thì mình sẽ đi vào rất là thông tin rất cụ thể. Chúng ta nói về một cái thiết bị sử dụng một cái accelerometer chạy ở tốc độ khoảng 200 đến 400 Hz, tức là nó sample khoảng 400 lần trên 1 giây. Chúng ta nói đến một cái microprocessor rất đơn giản, một cái chip ARM-based M3. Rồi, chúng ta có hai cái đấy và câu hỏi là bạn làm sao bạn chạy được một cái thuật toán mà trong vòng 6 tháng nó không hết một cái viên pin. Thì ta nói một cái viên pin là một viên pin sử dụng trên cái đồng hồ, nó có dung lượng gấp nhầm thì nó rơi vào cỡ khoảng 1200 đến 1500 mAh. Thì khi mà chúng ta đưa tất cả các thông số đấy thì tôi có thể nói với các bạn là để một cái thuật toán bạn sống sót được qua 6 tháng thì bạn không nên viết quá 100 dòng code. Đấy là điều đấy có nghĩa là gì? Điều đấy có nghĩa là bất kể bạn sử dụng thuật toán như thế nào, bạn sử dụng model như thế nào, bạn sử dụng bất cứ một cái khái niệm gì thì bạn phải làm tất cả thuật toán gói gọn trong vòng 100 dòng code. Với tất cả thuật toán chạy trên try này là gì? Là một thuật toán mà làm sao cho nó xử lý từng sample một trong số 400 sample mỗi giây đấy, để nó nhận dạng khi mà bạn gõ lên cái thiết bị đấy để nó trả lời cho bạn. Làm sao khi bạn đi bộ thì nó đến được số bước bạn đi, và khi bạn ngủ nó đo được giấc ngủ của bạn. Tất cả bạn có 100 dòng code để viết.
Cảm ơn anh đã chia sẻ. Em thì xuất phát từ giới làm về machine learning, cho nên là thực ra là theo em quan sát thì hầu hết cái giới về làm về machine learning vẫn bỏ ngỏ cái phần làm sao để thiết kế các thuật toán machine learning để có thể giảm thiểu cái energy consumption. Cái thứ này hình như là hầu hết vẫn đang bỏ quên, cho nên cái nhu cầu của các anh cái đấy có lẽ là cái đấy là một cái vấn đề rất là lớn cho lĩnh vực machine learning. Có khi có lẽ là không biết là bên Miss các anh ấy có phải redesign all algorithm, thiết kế lại tất cả các thuật toán hay là sử dụng sẵn, hay là có thể sử dụng những cái thuật toán sẵn có. Cảm ơn anh.
Thì câu hỏi này lúc nãy anh cũng vừa mới hỏi rồi, mình cũng xin trả lời lại là dĩ nhiên là không có thuật toán nào có sẵn có thể làm được như vậy, nên thông thường mình phải thiết kế lại từ đầu. Lúc nãy em quên không trả lời một câu hỏi tối qua là có publication hay paper nào mà nói về những thuật toán của Misfit dùng không, thì như tất cả các công ty khác thì các thuật toán của Misfit liên quan đến số bước đi hoặc là đo hoạt động hoặc đo giấc ngủ thì thông thường là đều được pha với dạng Python.
Any other? Maybe we'll take a pause on questions for now and have a little bit of fun, since this is the Math Institute, the greatest math institute in Vietnam. And so we can't have a talk without having kind of a math problem, right? This isn't really a math problem, but it is an exercise in thinking outside the box. And if you've seen this problem, and at stake is a Shine device. So I only have one though, so I'm sure everyone here can solve this problem. 9 dots. Okay. If you have to connect the dots with a line. And if who's seen this problem before? You know, you can connect it basically by 5 lines, right? And the question is, how can you do it with 4 lines? So who's seen this problem before? Okay, so all of you who have seen it are disqualified from this puzzle. So the question is, how can you do it in fewer than 5? And we're speaking Riemannian geometry here, right? So no infinite lines and whatnot. So you have to think outside the box. So who can do it in 4 or fewer lines? So let me explain the problem again. You have 9 dots. You know, much of what we do at Misfit, much of what we do in life is around thinking outside the box. So you can't lift up your pencil. So 5 straight lines, 1, 2, 4, 5 to connect it. So who can do it in 4? You've already seen this problem, so I think you're disqualified. Have you seen this problem before? First time? Yeah? So how would you do it?
Can I say?
Yeah, come on up. Okay, got it. That's exactly how you solve it. So the problem with thinking outside the box, you have to draw a line outside the box. Draw down, up. Congratulations.
Thank you.
Okay, well, thank you. If there's no other questions, I'll hand it back to Joe.
Cảm ơn anh Sony, một cái nội dung rất là thú vị và rất là đầy đủ, rất có nhiều những khía cạnh khác nhau từ cái sản phẩm của Misfit cho đến những cái thuật toán đứng đằng sau những cái sản phẩm đó, chia sẻ những cái kinh nghiệm của anh như mọi người đã từng thành ba cái startup khác nhau, cuối cùng có cả phần đố vui bất thường.